All right, so as we talked about vectors before, a couple things to think about with a vector. A vector is, like, if you look it up in the dictionary, it's going to say it's a mathematical object with magnitude and direction. Often magnitude is thought of as a length, but it doesn't have to be. It could be something like a speed or force, many other ideas. And then the idea of a direction of that vector. Vector is different than a point. So although this is kind of like the point -4, -6, it's really not the point -4, -6. A vector is, again, about magnitude and direction. So the -4 really refers to an x direction or an x change. Direction or x change. And similar for the -6, that's really a y direction more than it is a y value. So I'm going to draw it. So drawing stuff, -4, -6. My axes here and here. X direction, Y direction, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And so there's a point related there. And my vector is actually, if I start at the origin, I could consider it that vector. But a vector can start anywhere. I could have picked this vector up and started it somewhere else, like over there, and it still means a change of 4 and a change of 6 from wherever I start. So usually when we talk about magnitude, we talk about length. So then I want to use the Pythagorean theorem to figure out what is the length of that vector there. And as far as direction, we typically just use the standard means of direction from the beginning of trigonometry, which is from the positive x-axis, we measure counterclockwise. So that's what we're going to figure out for direction there. So as far as the length of the vector, we usually call that r, like a radius. It's also, if we call this vector something like v, with a little bar over it to indicate it's a vector, we would write vector v, and then it's kind of like absolute value, but not exactly. A double set of bars find out how long the vector is or what its magnitude is. So in this case, that's going to be the square root of the squares of -4 and -6. So 1636. That's going to be 4052.
Yep.
All right. Let's see. Is it essential to write that in lowest terms? If I need to do more with it, for sure. Otherwise, I don't recognize it as a perfect square. Let's see. 2 goes into 52 how many times? 25, 26 times. Oh, 2 goes into 26. 13 times. So I could reduce it, simplify it as twice the square root of 13. They're both good answers. I would be happy with either. So that's its magnitude. Its direction, to get direction, we typically, since these are x's and y's, arctangent is the go-to. So I know that the tangent of some angle can equal y, -6, over x, -4, which is, cleaning that up, negative over negative is a positive. 6 over 4 can be viewed as 3 over 2, or you could view it as a decimal if you wanted to. Now, tangent, remember, thinking back to unit circle, is slope. So we could say, oh, we want the angle that goes with a line that has a slope of 3/2. So if I sketch that out, change in y is 3. Let's say, so my grid's kind of running out of space there. I'm going to go down instead, 1, 2, 3, and then we'll go left, 1, 2, which, oh, that's this line right here. Cool. So I want an angle related to that right there. Standard angle that the arctangent knows about would be that angle right there, but that's not the angle I want. So what would I do to modify what the arctangent thinks about this? How do I get from here over to there?
At 180 degrees.
At 180 degrees or pi, whichever way we're going with. And this didn't state degrees or radians, but mostly the examples in this section use degrees. So we might modify that on our calculator. So I have two options. I can either say on my calculator it's pi plus the arctangent, Oops, letters are out of order. Of 3/2, or if we're focusing on degrees, we could make sure we write it as degrees and say it could be 180 degrees plus the arc tan of 3/2, and then I'm going to remind myself that ought to be in degrees too. So let's calculate that, see if it looks reasonable for this picture. And again, you need to be comfortable with your calculator. Is your calculator default to degree mode or radian mode? My Desmos defaults to radian. So I'm going to go with what the other problems in this book were doing and use degrees. So then I want 180 plus arc tangent, which you can just type, or you can pull it from the menu here as tangent inverse of 3/2. And it looks to be 236-ish degrees. And yeah, I'll buy that. 180 would be to the negative x-axis. So I think that my version of theta, the red one here, should be about 236. Was it 0.3, I think?
3.1, yeah.
Degrees. And again, they didn't mention how many decimal places, so take your pick.
If you do the rough estimate as your answer, that's fine.
Yes. Yeah. Yeah, and if this were a test question, then I'd be looking to see you did some write down. Anytime you whip out a calculator, always write down what you told your calculator. So if you gave this to your calculator, I'd want you to say, oh, well, this is what I told my calculator to do right there, or this is what I told my calculator to do right there. A sketch is a nice way to confirm you're telling your calculator to do the right thing. So that's always a good idea too.